total number of atoms in face-centered cubic unit cell will be 4. Understand this one? These all numbers are very important when we will solve the numerical at that time. Clear this thing? Yes. Okay. Now next one. This is what the end center. In end center or basic centered unit cell where the atoms are present, the particles or the atoms present at corner plus any two opposite face. If any corner means what total contribution will be 1. Any two opposite face means how much contribution will be there? Any two opposite face contribution will be 1 only, so total 2 atoms will be there. Okay. Now we will solve some questions so that it will be more clear. What is the question given? A solid is formed using A and B where A is present at corner. If A is present at corner, can you tell me what is the contribution from each corner?
1/8.
1/8. So contribution from each corner is 1/8. Total how many corners are there?
8 corners.
8 corners. Total how many A atoms will be there then?
1.
Because A is present at corner. So what is the total A at 1? Okay. Now next one. Present at corner. While B is present on faces. Okay. B is present on face. What is the contribution from each face? Each face? 1/2. 1/2. Total how many faces are there? 6. How many are there?
6.
6, right? So 3. So how many A atoms are there? 1. How many B atoms are there? 6. This is the formula. How many A atoms are there? 1 only. How many B atoms? 3. In this way we have to write down. Okay. Now next one. Can you tell me what will the formula here? Think.
So AB?
What will the formula here? AB?
Yes, sir.
A2B3.
A2?
B3.
Correct. Just 1 minute. I will join, my pencil is not working. Okay. So what will be the contribution from A? How much will be the contribution of A atom? Where A is present?
1.
1.
So A is present at corner, right? If A is present at corner, what is the contribution from the corner?
1 by 8.
1 by 8. Total, how many corners are there? 8. So
8.
contribution total will be 1. Where B is present?
On alternate faces.
B is present at alternate faces, right? Okay. What is the contribution from face?
1 by 2.
1 by 2. Alternate face means total how many face we have to consider then? Total 6 are there. So alternate means how many will be there?
3.
3 will be there.
Sir, but which 3?
Alternate one. Any 3 you take, alternate ones. So 3 will be there. So total 3 by 2. Right? So what is the formula then? Molecular formula.
A2B3.
You will get A, then next B 3 by 2. Can I write down this formula like this? A2B3. Right? So this is what your answer. So this is the formula. Clear this
Sir,
thing?
but
This contribution.
what do you mean by alternate phases, sir? Exactly.
Total how many phase we have?
6 phases.
So any 3 you consider like that.
Okay.
Okay.
Sir, but then any two of them will be adjacent, no, sir?
See, any 2 of them will be adjacent. They are trying to say that alternate phase means they are asking to consider half only, like that.
Okay, sir.
Now then we have Breves lattices. This is nothing but what? How the that structure will be there in different shapes will be there. Like some will be a cubic one, tetragonal, orthorhombic, rhomboidal. What will the shape? Like that. For that, total 7 system we have, and this 7 system further classified into 14 Breves lattices. Now here, what is the important thing that you have to remember is their age, their values of age length and age angle. So I told you at time of IPL. So how to remember this one? Can anyone tell? What is the age length of cubic unit cell?
All are equal.
All are equal. So A equal to B equal to C. Then I told you how to remember this thing. Next, what you have to write down? A
A
equal to
equal to
B
B, not equal C.
not equal to C. Then next one,
None of them are
A
equal.
not equal to B not equal to C. Again, same pattern. What will write down?
A equal B equal C.
A equal to B equal to C. Then again, A equal to B not equal to C. Then next, A not equal to B not equal to C. And last, again same, not equal to B not equal to C. How will remember their age angles values? Alpha equal to beta equal to gamma, and it will be a 90. Simple. You are sitting in room, right? What are those angles between two faces? There, 90, right? So alpha, beta, gamma, 90. Now for the first three, it will be same. For cubic, tetragonal, and orthorhombic, these values will be like same. Then next, what happens? Alpha, beta, and gamma will be there, but it will not be equal to 90. This is what the difference you have. Okay. Then how many remaining are three? For the last, all are not equal. Alpha not equal to beta, not equal to gamma, and not equal to 90. Now two are there. These two you have to remember. How will remember? For the hexagonal, alpha equal to beta equal to 90. And that gamma will be 120. That angle. Okay. The next one, alpha equal to gamma equal to 90, and beta will not be equal to 90. Now, this is what main we have cubic one, which we have in detail. And this is what we have written, that simple primitive unit cell, body centered cubic unit cell, face centered cubic unit cell. These three are the type of cubic unit cell that these three are there. Okay, in such a way that in tetragonal we have two. We don't have to study that. Then next one, orthorhombic we have four. Then rhombohedral we have one. Then hexagonal also we have one. Monoclinic two are there, and in the triclinic we have one. Total how many unit cell are there if you count this one? This total will be a 14. This is what the Brevis lattices PM means. In how many ways we can arrange that crystal by changing their edge angles and all, or changing their edge lengths. Okay, and how we'll remember starting what? CTOR sitter HMT. Cubic, tetragonal, orthorhombic, rhombohedral, hexagonal, monoclinic, and triclinic. Okay, so this is what we have, these three. Now try to solve this question. What is given information? Read that first statement. Where the X atoms are present,
Corner.
corners. Okay. So we'll write down contribution of X. So each corner contribute 1 8. Okay. What they have mentioned? X atoms are present at corner while Y atoms are at face centered. Okay. What is the contribution of Y?
Half.
Where it is present?
Face.
On the face.
On the faces. So what is the contribution from
Half.
single face? Half. Total
Half.
how many faces we have?
6.
6. Okay. There here total how many corners we have? 8. Okay. Then what they have mentioned? Then the formula of the compound would be if one of the X atom, okay, where X is present, corner, okay. If one of the X atom is missing, okay, then total how many corners we have to consider?
7.
7 only, okay, is missing from the corner of each unit cell. Then what is the formula then? Here it will be a 7 by 8, and here it will be 3. Can you tell me what will be the molecular formula then?
X7 by 20.
X will be 7 by 8. Y will be 3. What will the simpler formula?
X7 B20.
X7 by 20.
X7
Y20.
Y24. Clear this thing? Okay. Now next one. What is the question? A solid has a structure in which W atoms are located at the corners of cubic lattice. Okay. W atoms are located at corner. Total how many corners we have? 8 corners we have. And each corner atom contribute how much? 1 8. So 8 corners are there. So contribution from W will be 1. Okay. And O atoms are at the center of face edges. Means they are the O atoms are present at the edges. Okay. This is what the edge. Center of edge. This lines edge. Okay. So here these O atoms are present at edges. Okay. And sodium atoms are at the center of the cube. If sodium atoms are the center of the cube, total how many sodium atom will be there? What will the contribution from sodium then?
1 only.
Correct. So contribution of sodium. What will the contribution? 1. Okay. What they have mentioned for the edges? Okay. Can you tell me what will the contribution from the edge?
1 by 4.
You see here, one line is part of how many spheres? Consider this line is part of how many spheres?
4.
This line is part of how many spheres? Where it is involved? It is involved in this sphere also. It is part of this sphere also. It is part of this sphere also, and it is part of this sphere also, right? So one line is part of 4 spheres. So what is the contribution for single sphere then? Not a sphere for the single cube.
Can you explain that again?
Look at here. This is what we call it as edge. Now this line is part of how many cubes?
Okay, cubes. Yes, sir. Four.
Cube. So this is the another cube where this line is part. Then this is the another cube where this line is part, and this is one more. So single line is part of how many cubes?
Four cubes.
One single line. So what is the contribution of that line for a single cube?
1/4.
1/4. Okay, so that's the contribution. So we'll write down that thing. So what is the contribution of edge center to one cube? What is the contribution? 1/4. Okay. Total how many edges are there in one cube?
12.
12. So what is the and where is the oxygen is present? At edges. So contribution of O. One edge contribute 1/4. Total how many are there? 12. So what is the number of oxygen atoms?
3.
3. What is the formula then? You see,
NaO3W.
right? So molecular formula will be Na, then we'll have W, then O3. Clear this thing?
Yes.
Okay. Now we have to study in detail about the each cubic unit cell. It means what three are there, right? Simple cubic unit cell, FCC and BCC. These three we have to study in detail. Now one by one. What is the effective number of atoms in simple cubic unit cell? How many atoms are there? Total contribution. What is the contribution of simple cubic unit cell?
1. It's literally 1. Someone answer 1. It's
1.
for goodness sake.
One only, na? Simple cubic unit cell. What is the contribution? Total atoms per unit cell. One only, right? That only I am asking. So that is 1. Second thing, coordination number. Coordination number in solid state means what? Number of nearest neighbors. They are called as coordination number. Now look at it again. We'll take this diagram again. Now see this carefully. This is important now. Okay. We have this thing. Now I'm highlighting points here. Okay, this one. Okay, this corner is there. Okay, we are studying simple cubic unit cell, right? So this corner. Can you tell me this corner is attached to how many such corners things? It is attached here also, right?
Sir, 8.
It is attached here. This yellow one. Are you able to see it?
Yes.
Then it is attached here also. Yes or no?
Sir, 6 coordination number.
Then it is attached here also, no? Right? Again it is attached here also. Left side. Okay, then where it is attached? It is attached here also. This front one. This one
Yes.
here. Okay. Then where it is attached?
Sir, down one also.
What?
Down. This down side is also there here. Look at here. Here is also attached. 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 Here is also there. Any other is there? Any other place?
No, no, sir.
Any other is there where it can be directly attached? Is there any places there? Okay. Now look at here.
No, sir.
We'll take the same thing here. Okay. So that it will be more clear. Yellow one. Then this is also yellow one. Yellow ones. Okay. This one is there. Okay. There is further line from here. Right. This one. Then again there is further line on the here also and on the top also. These two I am writing here now. And top also here. Okay. So this we have. You can write down here this thing that these atoms are there. Better I will make circle here. Pairs are there, no? So those pairs. Okay. Now here, can you tell me what is the distance this is? What is the distance between this pink one and the yellow one?
Sir, edge
This one and
length.
this one. Age length. Which one we are studying? Simple cubic, in which all three are same. So consider A only. So can I write down this is A? This is also A. This is also A. This is also A. This is also A, and this is also A. I am talking about this distance. A. This is also A. This is also A. This is also A. This is also A, and this is also A. Right? Now one more thing. I am drawing here one line. I am drawing here now that face diagonal. This is face diagonal, right? Now here, and let's say I'm considering this as the green one. Now this for the face diagonal, this has fixed value, face diagonal, that distance, and the distance is root 2a. We'll see how it comes. We'll see in the FCC. The distance between this pink one and this green one, how much distance is there? Root 2a. Pink one and the yellow one, what is the distance? A. Clear this thing?
Yes.
Okay. Now you see here. Now for this one, for these pink atoms or those pairs, yellow ones are at which distance? What is the distance of yellow ones?
A.
A.
Yellow ones is at distance A. Okay, one thing. While another one we put, right? Which one we put here? Green one. What is the distance for the green one?
Root
The distance for root 2 I said, right? While for green one is at distance root 2a, right? Now you tell me which is the nearest one. Which one is the nearest one?
the yellow.
Yellow one is the nearest one. How many are there yellow?
6.
6. So what is the coordination number? What is the definition of coordination number? Number of nearest neighbor atoms. They are called as coordination. How many are the nearer to that pink one?
6.
6 are there. So what is the coordination number?
6.
So coordination number for simple cubic unit cell is what? 6. Clear this thing?
Yes.
Understand? So this is the second point. Now third one. The relation between A and R. What is the A? Edge length. What is the R? Radius of sphere or atom. Okay, A is what? Edge length. What is R? Radius of sphere or atom. Can you tell me what will the relation between A and R? Which type of unit cell we are studying?
Simple cube.
Simple cubic unit cell. Now look at here. Simple cubic unit cell. We'll go back here. Look at here. I'm asking about this one. This is A. Can I say, look at here now. This particular part, this part only, this much is R, radius of sphere. Can I say this part?
Yes.
Only this one, radius
Yes.
of sphere. And this one is also same thing, na? So this is R, this is R. What is the relation between A and R then?
A is equal to 2.
A equal to 2R. Okay. So same thing. What is the relation between A and R for simple cubic unit cell? A equal to 2R. Clear this thing? Okay. Now, next one thing is there which is known as packing efficiency. We'll cover that also, how it comes. But I think in IPL so we have covered that part. So for the simple cubic unit cell, that value comes as 52.4%. Means this much volume is occupied by the atoms. Remaining will be a void, free space in simple cubic unit cell. Then fifth one, nearest neighbors and distance. Now look at it. We'll see this diagram again. Now I'm writing here one thing. Table I'm making. For that pink atom. Okay. First nearest neighbor. Which color atom will be the first nearest neighbor atom for the pink atom?
Yes.
Yellow one, right? So that I am writing. Yellow one will be there, right? So which atom will be the nearest neighbor? Yellow one. Okay. Can you tell me what is the distance between that pink and yellow one?
A. 2R.
A will be the distance. Okay. Total how many will be there? Such yellow atoms?
6.
6. Okay. This is the first nearest neighbor. Now second one. Second nearest neighbor.
Excuse me, sir, could you check the waiting room?
Yes. Now look at it. This is what the body, this is what the face diagonal. There is one more thing known as body diagonal. From here to here, till here. Are you understanding? From here to here. You can consider two opposite faces in your room. From one corner to exactly opposite that corner. That is body diagonal. And the distance, that value of body diagonal will be a root 3a. Now you tell me which value. Let's suppose we'll put one more color here. This black one, let's suppose we are putting. This one is there. Now you tell me for this pink one, which is the most nearer? For this pink atom, which atom is very near to it? Yellow one, green one, or this black one?
Yellow.
Yellow one. That we are written first nearest neighbor. And what is that distance? A. How many are there? Total 6. Now, okay, first is over. First nearest neighbor. What is the second nearest neighbor now? This green atom or the black one?
Agree.
Green atom will be the nearest neighbor or the black one? Which one will be there? Smallest value, which one will have? Nearest one.
Green.
Green one will be there. Okay. So green one will be there. What is the distance?
Root 2.
Root 2a. So if you study this thing in this, it's like big giant compound, we'll get to know that such type of body diagonal, there 12 are possible. How many are possible? 12 are possible. Like from here to here, one, like that you can calculate. Here to here, then from here to here to here, from here to here. Okay, like that you can calculate. 12 will be there. So that value you can directly remember also. Okay. What is the third nearest neighbor and distance?
The black one.
Which one will be there? Black one. And what will the distance?
Root.
Root 3a. Okay. And this will be a total 8 will be there. Directly you can remember. 6, 12, 8. Clear this thing?
Yes.
Okay. What is the coordination number in the simple cubic unit cell? Coordination number means what? First nearest atoms. How many are there? 6 are there. So coordination number will be the 6. What is the distance for that first nearest neighbor?
A.
A. And the okay. And what is the relation between E and R? A equal to 2R. Are you understanding this?
Yes.
Okay. Then we'll study about the second one. Second one is what? We'll talk about the BCC unit cell. Now you tell me, what is that effective number of atoms in BCC unit cell n value? Contribution total.
2.
2 will be there. Okay. Now next we have to study about the coordination number. What will the coordination number? Coordination number means what? How many first nearest neighbor will be there? Okay. Now look at here. I am drawing the structure here. So at corner there will be atoms, right? BCC is there. So where atoms will present? Corners. All 8 corners atoms will be there. And where other atoms will be present? Corner plus what?
1 in the center.
Center. So at center there will be atom. So there will be atom at center. Okay. Okay. Can someone tell me what can be the distance between this atom and this center atom? What can be the distance? Let's say we are sitting in room. You observe from one corner on the top side to exactly opposite corner on the bottom side. That is what your body diagonal? Yes or no?
Yes.
And this
Half of the
pink
body.
one is present only directly at the center. So what will the distance between this green one and this pink one?
Root 3 by 2 side length.
Root 3a by 2, right? Are you understanding?
Yeah, yes.
Okay, so what will be this distance? This distance will be root 3a by 2. Okay, and this will be the nearest distance. Now you tell me what can be the coordination number here? Think this pink atom is attached to how many nearest neighbor atoms?
8.
8, right? So see here, this is one, this is second. From here to here also same distance. From here to here also same. From here to here also same. Here to here. Let's say you are standing at the center of that room. Okay, all 8 corners will be at same distance. And what will the that distance? Root 3a by 2. So what is the coordination number then? 8, right? Clear?
Yes.
And third thing, now we have to find out the nearest neighbor and the distance. Okay, same diagram will take. Now look at here. What will the distance here? See, one more thing. You can check the nearest neighbor with respect to this pink one, or else you can check with the green one also. You will get same value. How? Look at here. You can check with this one also. How many are directly attached to the center one, nearest one? We can find out like one will be here, one will be here, one will be here, one will be here, like that. Total 4 you will get. Okay, nearest means what? It will be at center, right? Not here. At center it will be there like here. So it will be 8 will be there. Okay, so we'll calculate from here now. The green one. Can you tell me what will the distance here?
Root 2a.
This one.
Root 2a, sir.
Yeah, root 2.
Phase diagonal, root 2a. Clear one thing? Okay. Now, okay. For green one, we'll consider with respect to green. For green one, what is the first nearest neighbor? Which one? Which color atom? First nearest neighbor. Which one will be there?
Sir, green one only, sir.
With respect to green, we are calculating. We can calculate with respect to green also, with respect to pink also, we'll get same thing. So with respect to green, which color?
Sir, another
Purple.
Huh? This pink one will be there, right?
Yeah, pink purple.
Okay. What will the distance here? Pink one from green. This pink is at which distance?
sir, root 3a.
What distance is there? Root 3a by 2. Okay. And total how many will be there such? We will get 8. So this is first nearest neighbor. Now second one. Second nearest neighbor. Now look at here.
Will be the other green atom.
We are calculating with respect to this green. So better or easy, we'll put another color here. Okay, this is now second nearest. Okay, can you tell me what will the distance? And one more thing we'll put here. This one will also be there. You see, one top corner to bottom one. We are discussing with respect to this one. This is the first nearest, root 3a by 2. What is the value here? Root 2a. And what is the distance between this one and this one?
Root 3a.
See here, this one and this one. What is the distance? Green and pink. root 3a by 2. Green and blue one, root 2a, and green and this one. What is the distance here?
Root 3.
This is body diagonal, no? So root 3. So which one is closer then? Pink, no. First we are written, okay. Next one, this blue one or the orange one? Which one is closer?
Blue.
With respect to green, I am talking about. Blue one is closer. What is the distance?
Root 2a.
But sir, for the green one also, there are other green atoms directly attached, right?
So we are discussing. When we are discussing with the green one, we'll talk about this thing.
Okay, okay.
Okay. So another green atom is also attached. Correct. Which one is closer now? Another green one or this blue one?
Green.
Green one. What is the distance here in green?
A.
A.
A. And what is the distance with this blue one?
Root 2.
Then now you tell me which is the nearest one.
So another green atom.
Another green atom will be the nearest one. And what distance will be there? What is the distance? A only, na? And total you will get such 6 things. Okay. Then now third one. Third one will be which one?
The blue one.
Blue one, right? What is the distance?
Root 2.
Root 2a. And such a 12 atom will be there. Clear this thing? See here. Root 2a looks like this one, but you see here, the distance between this another green atom is A only. Which value is smaller? A only, right? So this thing will be there. Clear?
Yeah.
Okay. Now one more thing. Now we have to see a relation between A and R. Now I am drawing here body diagonal. It will start from here and end here. Okay. So this is what the body diagonal. Now I have to find out distance of this body diagonal. Can I find out this distance? Now here corner is there, so sphere will be there. Yes or no? Right? Same sphere will be present there at another corner also. And as it is BCC, so one sphere will present at center also. Yes or no? Are you understanding this?
Yes.
Okay. How will find out this distance then? How I will find out distance? Now look at here.
Sir, root 3a is equal to 4r.
Look at here. Consider this as A, this one. Okay. This as B and this as C. This is what the body diagonal is there. Consider this as the triangle. Can you tell me the length of AC? That's what the body diagonal, right? Here it is 2r. Can I say? Radius of sphere is r. Distance from here to here it is 2r. Green one. Green sphere is there. Radius will be a what? R. This is what the entire diameter. No, it will be 2r. Then again, this value will be r. Radius of this sphere. Again here it will be r. Yes or no?
Yes.
Okay, so this is one thing. Okay. Can you tell me what is that value then? Can I write down AC square will be equal to AB square plus BC square? Can I use this thing, Pythagoras? To find out the AC value. Can I use this thing?
Yes.
Okay. Now you tell me what is the value of AB?
Yes.
A and B. It is edge length A only.
Yes.
And B and C is what? Face
Root 2.
diagonal. B and C is face diagonal, right? B to C.
Yes, sir. Root 2.
So what is the value? A square plus root 2a square. This value will be equal to what? A square plus 2a square. That will be equal to 3a square. That is the value of AC square. What is the value of AC only then? Length of AC? Root 3a. Okay. Now if you see directly here, AC is your body diagonal. From here, what value is looking like?
Yes. 4R is
A
equal
to
to
C. R plus 2R plus R. So AC is body diagonal, right? What value you are getting for the body diagonal from here? R plus 2R plus R. That is 4R. These two values are same only. Let's just equate them. So what will get then? 4R equal to root 3A. So this is the relation between A and R. Edge length and radius of sphere or atom. Are you understanding this? See here. We have to find out the relation between A and R. How will find out? We know this is BCC structure. So in BCC, atoms will be present at corner plus body, right? So corner atoms will be there. That atom they are spherical in nature, so their radius will be r. Here also their radius will be r. Okay. One atom is present at center. Its radius is r only, but total we'll consider now here as 2r. So what is the distance from A to C? That is 4r. That is body diagonal. I need to find out again this value of AC. So this is what the right angle triangle. So AC square will be equal to AB square plus BC square. What is the value of AB? That is edge length A. So A square plus we have BC. What is the value of BC? Root 2A. So A square plus root 2A square. What value will get? The entire AC value will get root 3A. And the same AC value is also is 4R. So I just equated both of them. So what is the value? 4R equal to root 3A. So this is the relation between R and A in case of BCC. Do you understand this?
yes.
Okay. Now next one. What is the next one remaining now? We
FCC.
have seen simple. Then next BCC. Now what is the next one?
FCC.
FCC unit cell. Now in FCC unit cell, where atoms are present?
Sir, on
In
the face
FCC,
and
on the face and
corners.
correct. So total, what is the contribution in FCC? That is 4. Okay. Now look at here.
we'll consider with respect to this pink one. Okay, face will be here, right? Half inside, half outside. Okay, can you tell me what will the distance between this one? What will the distance? Hmm?
A by root 2.
Distance from here to here.
Yeah, A by root.
A by
Root
A
2.
by what? Root 2. Okay, huh? A by root 2 will be there. Okay, because this entire distance is root 2a, right? So root 2a by 2, that is a by root 2 will get. Okay, so this is one thing. Okay, we'll see the nearest one directly. Now from here, this is which one? FCC. So where face will be there? Here also face is present, right? Now here, what will the distance? What can be the distance? Can we calculate that?
Yes, sir.
Right? Okay. So n is
So
4.
root over 3 by 2. A.
Root 2a, how much will you get?
Root over 3 by 2A.
First is this one. Okay. Second thing, FCC, that coordination number. Again, we have to see the entire that complex structure. Directly, you'll get 12 things there. Means 12 atoms will be the nearest one. Which one? This one. Because this is the smallest one will be there. Okay. Now here, from here to here, from here to here, there is also atom, right? From this pink to another one. So we'll give another color there. Let's show the red one. So red is at which distance?
A.
Red is at a distance. Okay. And this distance also we have to calculate this one. Okay. Now look at it. I'm writing that thing. For with respect to pink one we are going now. Okay. First nearest neighbor will be which one? Which one will be the first nearest neighbor?
So the blue one.
Blue one, right? Okay. It is at what distance?
A by root.
A by root 2. Okay. And total how many will be there? Directly you can write down that will be 12. Okay. So first nearest. Second nearest.